Hey physics class, how's it going? We got next part of our forces unit, which is talking about inclined planes. So last week we talked about friction and forces at angles, kind of like this, where this week we'll be talking more about an object that is going to be on an angle, so kind of like a hill or a slope or however you want to talk about it, but an actual object on an actual, we call it an inclined plane, again, something that has a slope. You can imagine, again, some kind of object on a hill, whether it's rolling down, sliding down, something like that. So that's this week's topic. I'm going to break it into two sections where the first helpful videos, there'll be 3 videos talking about just an object and on that actual inclined plane. And then the next set of helpful videos will be talking about, well, what if someone's actually pulling something on that inclined plane? So the first set of videos, which will be done on Tuesday and put out, so you're probably watching this sometime after Tuesday, will be just this. We have an object on an inclined plane, and then it starts to move. Where our second set of videos, we're going to talk about if we have an object on an inclined plane, and someone is pulling it, whether it's going up or going down, we'll have to figure out. But now there's also going to be a force applied by somebody. Again, imagine carrying a little child on a sled up a hill. So there's an actual force applied still on this actual angle. So there's kind of our 2 parts for this week. So let's kind of break down our first part, one object on this actual, right now not an inclined plane, right now here. So the one big thing is we have talked about why does something actually start moving. In the sense of this object, not moving right now, still not moving, still not moving, still not moving, and now it's moving. So why do I, when I get a higher angle here, as that angle goes up, eventually this object starts moving. So what changes that finally starts making this object move? And well, let's think about the things that are interacting in the sense of like I'm not pulling or pulling on this, so there can only really be so many things interacting with this actual object and what it's on. One, we know the force of gravity is pushing down on it. 2, we know that there's a force normal pushing back on this. And then there's going to be some kind of force of friction that's going to be in between these 2 objects. And so we talked about that force of friction last week. So why, when I'm at this angle, does the object not move? And at this angle, it does move. And let's try and think about this. So right here, the force of gravity pushing down, and there's some friction holding it on this actual board. Now, we still have a force of gravity, but it seems like friction isn't winning anymore. Friction is starting to lose. So how does friction change as the angle goes up? And that's going to be our big question, because that's really the most important thing that's changing here, is our force of friction is changing as the board goes up. Okay, so I mean that kind of makes maybe sense, as in the sense of like there's less friction. And let's go to the very extreme percentage. If we're here, there's friction. If I go all the way up to 90, well, now there's no friction, okay? This is kind of a crash and bang, which, it makes sense. So at 0 degrees, full friction, and at 90 degrees, 0 friction. That's falling. All right, that makes sense. And obviously, it's going to get less and less and less as I go up at my angle. This kind of is similar to last week when I pulled up last week with an angle. So if you remember last week, we had this kind of question. As I pulled up, well, force normal started to change. And the reason it started to change is because in the y direction, I was helping the table. So that's why force normal changed. And in this instance, force normal is also going to change. Why is force normal going to change? And that's a little bit more of a complicated question, but here, let's go through this. We have a block here, again, not moving. And then we are going to do this. So the big thing that we're going to have to learn from this week, and I'd love to do a lab with you guys, and thank you so much for you guys coming in for the lab last week. That was great. The difference that changes, when we have a block that's like this, and I'm going to hold it for now, force of gravity can only always pull it to the center. The difference is that force normal is only going to be able to push back at a 90-degree angle of whatever it's on. So sure, force of gravity is going to go straight down here, and I'll link some good videos to show this, but force normal actually points 90 degrees from where it's at. So force normal is not going straight up anymore. It's not the same as gravity. We're going to have to break it into, again, different parts. So force normal is going to change as we go. All right, and that's going to be the big thing. When force normal changes, that means our friction is going to change, because we know friction formula is coefficient of friction, that mu, which doesn't change. That's never going to change when we're on here. When you have an object with a certain coefficient, that stays the same. So when you found the cork last week at 0.34, or you found something else, that doesn't change. It doesn't even matter on the angle. You still have those two interacting. The force normal does change, in the sense of, like, again, how much does the board have to work to keep it up? Well, it has to fully work, it has to do no work, and there'll be some variation of percentage in between. So in the next video, what I'm going to do is I'm going to describe how to break apart our forces on an inclined plane. And we'll talk about how to get force normal, and we're going to talk about this new thing called force parallel, which is gravity helping it go down the actual board. All right, class, thanks.